All right, this is Unit 4 review from College Board. In the question, these again are going to be involving derivative type questions. F at 5 equals 3. The derivative of 5 equals 4. What is the estimate for f at 4.8 using local linear approximation? That's another way of saying the tangent line. So I need a tangent line, and then I'm going to use that tangent line to approximate. In the question, it tells you the x and the y value, and it tells you the slope. And so the slope at 4 is equal to, slope at 5 is equal to 4. It gives you all the information. The equation of the line is this in HK form, and then use that and plug in 4.8 and get your answer. So 4.8 take away 5 is negative 0.2. That's negative 0.8, and then that answer is 2.2. And you have your answer. Number 2. My goal is to keep this under an hour. Let's see how close I get. A particle moves along the x-axis so that t is greater than 0. Its position is given. At what time is the particle at rest? So if it gives you the position, then the velocity gives you whether it's at rest or not. So how do I find the velocity given its position? And the answer is you take the derivative. So the derivative is 6t squared, subtract 42t plus 72. That's the derivative. Make it equal to 0, then the particle is at rest, and now solve it. So first I'm going to divide everything by 6. So 6 goes into everything evenly. I'm going to factor this. The two numbers are negative 3 and negative 4. And then if I solve it, each factor has a solution. At 3 and at 4 seconds, the velocity is 0. And the answer is E. In number 4, it says I can use my calculator. So that's what I'm going to do. So press pause if you need to. Take out your calculator. So in number 4, they give you, let me move this just for a moment. They give you an equation, and the equation is the velocity, and you're supposed to find the acceleration at 4, and how would you do that with your calculator? So let's just, first of all, I'm going to clear this. Make sure your calculator is in radians, RAD. And so if you're given velocity and asked to find acceleration, that's the derivative. So make sure you find the derivative. So it's menu, calculus, derivative. And it is derivative at a point. So it's when, in our case, it's t. So let's change that to a t. And then we're looking for the value when t equals 4. So can we do that? Press enter. And then inside, we're going to type it in, which is 3 plus 4.1 cosine .9t. There it is. So that's all we need to do. Press Control Enter, and I get the answer 1.632, or 633 if you look up, if you round it. So how you would show that is you took the derivative of the velocity at t equals 4, right? You took the derivative of the velocity at t equals 4. So the acceleration at 4 is the derivative of the velocity at 4, and we said the answer is 1.633. Number 4, we get to use our calculator again. A particle moves along a line so that at time t, the position is given by this. And it says, what is the velocity of the particle when the acceleration is 0? So we actually have to start here and then work back to here. So when is the acceleration 0? What's the connection to position? And so the answer is I have to take the second derivative. So I'm going to show you where that button is. The second derivative of position is acceleration. So I'm going to solve an equation. So I'm going to go Menu. I'm going to solve an equation. And I need the second derivative. So if you look here, look beside the number 9. So do you see this button right here beside the number 9? Press it. And then you get all kinds of things. And I've already highlighted it. That's the second derivative button. See that little number 2? So we're going to press it. And then the variable we're using is t. So let's use t. And then you're going to type in the equation. So let me do that. I'm just going to move the book for a second and type it in so I can see it. So that's negative 4 cosine t. So move the cursor. Subtract t squared over 2 plus 10. So I'm just making sure, did I type it in correctly? Negative 4 cosine t, subtract t squared over 2 plus 10. So we're doing an equation. So it's the second derivative equal to 0 and then comma t. So that's the equation we're doing. So the answer is that, what happened? Oh, you know what? Because it's trigonometric, I need a restriction. So in the question, it says from 0 to pi over 2. Did you see that? So because it's trigonometric, at the end of this, I'm going to go control equals, and I'm going to put in the restriction. So I need that vertical line, and then the restriction goes from 0, and then go press control equals again, and it's less than or equal to. And I'm just typing in the restriction, t, and then control equals, same one again, less than or equal to pi. All right, so at the end, I put down the restriction, so it only solves it from 0 to pi. Now I get the answer 1.318. Okay, now what do? That's when the acceleration is 0. The next part of the question is, what is the velocity at that time? So the velocity is just the derivative. So if I press this button again, just the derivative would be that button. So I just want the derivative of the position. So again, negative 4 cosine double check, did I type it in correctly? And then I want to evaluate. So control equals. And, oops, this is the evaluate button right there. So I want to evaluate it when t equals. And now I'm just going to copy paste. So I'm going to highlight over this. And I'm going to go control C. And then move down. And then go control V. And then that's going to give me my answer. So the velocity at that time is 2.555. So I got the answer. I'm going to write down what I did to begin with. So I took the second derivative equal to 0, and t equaled 1.318. Then I found the velocity by taking the derivative of the position. I plugged that value in and got 2.55, and that's what gave me the answer using my calculator. Number 5. In number 5, a bug begins to crawl up a wire. The velocity of the bug is given. So this is the velocity. Don't think this is the bug crawling up or down. This is the velocity. So if it's positive, if it's above, it's going up. And if it's negative, it's crawling down. That's all. So this is not a bug crawling along here at all. And it's from 0 to 8. So given that, at what time does the bug change direction? So if this is a velocity graph, it would change direction when it goes from positive to negative. So at what time does it change from a positive velocity to a negative velocity? And the answer is at 6. And you have your answer. Number 6, I get to use my calculator. Number 6, the velocity of a particle moving along the axis is given. The velocity is given. Which of the following statements describes the motion at 1? So before I look at the options, I'm going to find the velocity at 1 to understand the motion of what's happening. I also need to know the acceleration. So let me do that. So again, we're doing number 6. So first of all, the velocity, how would I do that? And then the thing. So let me show you another technique we could use that may or may not be quicker. I can press the graphing button, or this, if you press this, it's called the toggle button, you know, the shaky calculator. If you press it, you'll go right to the graph. And you can define a function this way. So you can press tab, and then you could just type it in. So that's the square root of, now for this you can't use the variable t, it has to be x. So I'm going to use x. So the square root of x, subtract cosine e to the x. Make sure you press this e right here, right? Don't press the e on the bottom of the keyboard. So isn't that a fun looking graph right there? It kind of squiggles up to the right, but it's defined now. That's what I wanted. Press the toggle button for the calculator. And now I can use it without having to retype it in more than once. So I want to know what the velocity is. That's what was given. So if I type in F1 at x, and then if I do the vertical line, I can just evaluate the function at whatever value I want. So in this case, I want to know what it is at 1. So evaluate the function at 1, and what do you notice? It's a positive value. Then I want to take the derivative, and again, we're using x. And again, we're going to evaluate at 1. And so what I'm looking for is it positive, negative, or 0? So the velocity is positive, and the acceleration is positive. So I'm going to write down what I did. So the velocity at 1 is 1.9. The acceleration at 1 is the derivative, right, at 1. That answer is 1.6. And so both values are positive. So if the velocity is positive, we're moving to the right, and this one's positive, right? So we're moving to the right with a positive acceleration. So the answer to that is B. Turn the page. All right, the table above gives the distance in miles that a car was traveled. So this is a position in terms of it. During a 6-hour trip, the graph of the function is increasing concave up. Based on the information, which of the following could be the velocity of the car at 3? So velocity is slope, right? It is the derivative. So if I find the slope around 3, that would give me an approximate answer. So if I don't know anything about velocity, velocity is the slope between 2 points of the position. So we're going to go in front and behind. How do I find the slope there? So that's 150 take away 55. And that's 4 take away 2. That's what I'm doing. So if I was going to just quickly approximate this, I would say that. So I would just quickly, like, it's not quite, right? It's 95 divided by 2, right? But whatever, that's an approximation. It's already an approximation, so why not make it approximate? And then which of these answers is closest to it? And that's a good estimate for the velocity at that time. 8. we have a differentiable function, f at 3 equals 2. The derivative of 3 equals 5. Use the tangent line. So as soon as I hear that, this is what I'm doing. I already know that x is 3, y is 2. The slope is 5. So the equation is y equals 5. X subtract 3 plus 2. And it says, if the tangent line to the graph of x equals 3 is used to approximate as 0. So if we use this to approximate as 0, that means we make it equal to 0 and solve it. So there's different ways you can think through this. I am going to subtract 2. I'm going to subtract 2, divide by 5, and then add 3. So negative 2 divided by 5 is negative 0.4 plus 3. And so that gives me the answer 2.6. You could also distribute, right? And so if you distribute it, you get this answer. And you'd have to know that's 2.6. I mean, you could know it's 2 and a little bit. It's not 3. It's between 2 and 3, right? 15 over 5 would be 3. So it's between 2 and 3. That's the only answer between 2 and 3. Number 9. Another calculator question. A particle moves along the x-axis. In it, you're given the velocity. And what's the acceleration if you know velocity? So the connection between acceleration and velocity, they're derivatives, right? So, in other words, what will I do with my calculator? So I'm going to do the derivative. I can use any variable for this. So t, it's only with the graph that they want x. And so this is t squared. And then it's ln t plus 2. And then double check. So that's the derivative of t squared ln t plus 2 at t equals 6. And I get 29.453. So the derivative at 6, 29.453, and you have your answer. Number 10. Number 10 is, there's number 10. It's a limit question, so you always start with evaluating it. So if you plug 0 in, I get 0 squared. Cosine at 0 is 1, and 1 take away 1 is 0. This is indeterminate. This is L'Hopital's rule. So L'Hopital's rule is you take the derivative of the numerator, the derivative of the denominator. So the derivative of 1 is 0. The derivative of cosine is negative sine, but the two negatives make it positive. Again, if you plug in 0, 2 times 0 is 0. The value of sine at 0 is 0. It's indeterminate. Again, take the derivative a second time. Now you have 2. The derivative of sine is cosine. Now plug in 0. The value of cosine at 0 is 1. So the answer is 2. Done. Number 11. In number 11, you're given the position. And when t equals pi, it says the position of a particle moving along there. When t equals pi, the acceleration of the particle is what? So if you're given position, it's the second derivative at pi. So can we do that? The second derivative at pi, it will give me the acceleration. Oh, and you don't get a calculator. Ha, I was going to do a calculator. No calculator. I got used to it. I can do this without a calculator. Could you? Let's try it. So the derivative of sine is cosine, but there's a double hook. So the derivative of 2t is 2. The derivative of cosine is negative sine, so it's positive. And then again, the derivative of 3t is 3. So there's the first derivative. How about the second derivative? What would it look like? The derivative of cosine is negative sine. The derivative of 2t is 2, and we already have a 2. So if you multiply it together, it's 4. The derivative of sine is cosine. The derivative of 3t is 3. We already have a 3. So 3 times 3 is 9. And then we're going to plug in the value of pi and evaluate knowing our unit circle. Now, at 2 pi, if we need to, 2 pi is right here. The y value there for sine is 0. 3 pi is actually on the left. So it goes 1 pi, 2 pi, 3 pi. Here on the left is 3 pi. That's negative 1, 0. So the x coordinate there is negative 1. So ultimately I'm going 9 times negative 1. So my answer is negative 9, if you know your unit circle. So that answer is E. 12. At t is greater than 0 hours, h is a differentiable function of t that gives the temperature in degrees Celsius at an Arctic weather station. So t is in hours, and what's inside is the temperature. So what does this mean then? The derivative. So if I see derivative, it means rate. So the rate at what time? So at 24 hours, what's the rate of the temperature? Is the temperature increasing or decreasing? At what rate is that happening? That's what I'm looking for. So the change in temperature during the first day, I'm looking for it at 24 hours. The change in temperature during the 24th hour, that's a good one. The average rate, no. The rate at which the temperature is changing during the first day, no. During hour 24. The rate at which the temperature is changing at the end of the 24th hour. And it's during is what we're looking for. So during the 24th hour, what is the temperature changing? How is it changing? And you have the answer. Number 13. Let f be a function defined that way. And let g be a differential function with a derivative. It is known that the limit as x approaches infinity for g at x is infinity. So what's the value of this? Let's see if we can put this together. F at x is 2x plus 3e to the negative 5x. The denominator is just g at x. I don't even know what g at x is. But this is what I do know. As you plug in large numbers for x, this with the negative exponent is actually a fraction. So you can think of it this way. So as I put in large numbers for x, this is going to 0. But 2 times infinity, this is going to infinity. So if you put them together, it's going to infinity. And in the question, it says this is going to infinity. That's what this is above. This is indeterminate, infinity over infinity. So this is L'Hopital's rule. So I'm going to take the derivative of the numerator and denominator. So the derivative of 2x is 2. The derivative of e is copy it. And the derivative of negative 5x is negative 5. The derivative of g is given in the question. That's 1 over x plus 4 cosine 5 over x. So now we need to conceptually understand what's happening here. So I see a negative exponent. This is a fraction. And as you plug in large numbers into the denominator, all of this is going to 0 because of that fraction. I see 1 over x. All of this is going to 0. I see 5 over x. This is going to 0. So what am I left with? So as I plug in large numbers, I have a 2. If I add 0, it still stays 2. 1 over x is 0. So if I add that, it doesn't change anything. Inside the parentheses, it's going to 0. But the value of cosine at 0 is 1. So in the denominator, I have 4 times 1. So if I put that together, this is approaching 1/2. Another limit question. So if I plug in 0 for x, I get e to the 0, which is 1. So 6 take away 2 take away 4, that's 0. Plug in 0 for x, 2 times 0 is 0. The value of sine at 0 is 0. So we're going to do L'Hopital's rule. The derivative is 6e to the 4x times 4. The next one is negative 2e to the 3x times 3. The derivative of negative 4 is 0. The derivative of sine is cosine, and it needs the hook 2. We're going to do the same work right here. So I'm going to plug in 0 for x. So that leaves me with 24. I'm going to plug in 0 for x. That leaves me with negative 6. I'm going to plug in 0. The value of cosine at 0 is 1. So 2 times 1 is 2. So this is 18 divided by 2. So the answer is 9. Number 15. A particle moves along a hyperbola. X times y equals 15. At a certain time, x is equal to 3. Dx by dt is equal to 6. Which of the following is the true about y at this instant? So, this is what we're going to do. I'm going to take the derivative using the product rule. That is the, and by the way, I also know what y equals, because x times y is 15. If x is 3, y must be 5, because 3 times 5 is 15. All right, the derivative is the product rule. That's the first times the derivative of the second. And this is with respect to time. Plus the second times the derivative of the first with respect to time. And the derivative of 15 is 0. Now we have these values to plug in. So x is 3. Y is 5. Dx by dt is 6. And now we're going to solve it. This is 30. So I'm going to subtract 30, and then I'm going to divide by 3. So dy by dt is equal to negative 10. That is the rate that y is changing. It is decreasing by that value. So which one says that y is decreasing by 10? And you have your answer. Number 16. This is a fun one. So this one took me a while to think through. But thankfully I did it before the video, so I'm not just thinking out loud with you. So for number 16, you have a model car. You're allowed to use a calculator. I was actually doing this without a calculator, which kind of frustrated me. And you have a diagram here. And so ultimately the question is saying, can you find the rate that z is changing when the point here is 23 and 4? So exactly at that point, at what rate is z changing? And it's going as it's moving this way. So as x is getting bigger, z is getting bigger until it goes below, and then it would get shorter again. And that's the question. At what rate is z changing? So my big question is dz by dt. That's what I'm looking for. I want to see a relationship here where I can create an equation. And so I created a right triangle. And so I have this whole thing. I got the x, which is 23, the y, which is 4, and z, which I could find too if I need to, using my calculator. So this is what I'm going to write down, the Pythagorean Theorem. All of these are changing with time. None of it is a constant. So I take the derivative with respect to time right away. So I need that hook with respect to time every time I take the derivative. Now, here was my challenge. My challenge was, I don't know how fast y is changing. I'm only given how fast x is changing. So I have too many rates going on, and I don't have any information about it. So what do? Is I have to change this. So this would be helpful, but I need to be able to write y in terms of x and then go that direction. So in the question it says the equation of a circle is this. So I know the center is at 20 and 0. And I can figure out the radius of that. So that's the radius. 20 take away 23. This is 3. This is 4. This is a 3, 4, 5 triangle. This radius is 5. So I want to know what y equals, and then I'm going to plug it back in. So I got 5 squared, which is 25, subtract x minus 20 squared. And then I would take the square root of that, right? So that's what I'm going to plug back in. That's what y equals. In fact, I don't even need the square root. I just need y squared, to be honest. So I'm going to come back here. X squared, we just said that y squared is 25 subtract x minus 20 squared. And now I'm going to take the derivative, but I'm going to take it with respect to time when I take the derivative. So first of all, before I take the derivative, I'm going to do a little bit of algebra. So if you need to, you can actually use your calculator to expand this. So I'm going to do that. So nice to know different function. Go menu, go algebra, and expand. So let's do that to begin with. So that's x squared plus 25 subtract x subtract 20 squared. So if I expand it, I get 40x subtract 375. Why does it feel wrong? Oh, I got it. Okay. So 40x subtract 375. Now I can take the derivative. So the derivative of 40x is 40 dx by dt. That's 0. This is 2z dz by dt. So I have a rate for x. So dx by dt, I'm given that. That's 2. The z, am I given what z equals? No, but I can find it because it's a right triangle to know what z is at that time. So if I just drew the right triangle, this is 23, this is 4. I could solve for that. So ultimately it's the square root of 23 squared plus 4 squared. So that hypotenuse is the square root of 545. That's what z is. The square root of 545. And my goal is to find dz by dt. So I'm going to divide, and that will give me the answer. So I got 40 over the square root of 545. This. So what has that answer? 40 over the square root of 545. That is as tough a question as you're going to get. And the answer is C. Oh, and then I got to answer the next part. Is it moving away or towards? So sorry. So B has the same one, right? It is moving away. So as it's moving away from the origin, not closer. So the answer is B, and it's moving away. All right, number 17, nowhere is challenging. What's the limit? This is indeterminate. So it's L'Hopital's rule. So the derivative of e to the x is e to the x. The derivative of cosine is negative sine, but the two negatives make it positive. The derivative of negative 2x is negative 2. That's 2x minus 2. Plug in 0 again. I get negative 2 on the bottom. This is 1. This is 0. And that's negative 2. So if I put this together, I get negative 1 over negative 2. So that answer is positive a half. Turn the page. Number 18. If cosine x is the derivative of f and the derivative of g is 1, if f at 0 equals g at 0, then what's the limit as x approaches 0 for this? So if both of them equal 0, it's indeterminate. So then I take the derivative of the numerator and denominator. So what happens if you evaluate the derivative? So the derivative of g at x is 1. So now I need this. The derivative of f at x is cosine. And the derivative of g at x is 1. So it's cosine over 1. So plug in 0 for x. The value of cosine at 0, it's 1. And you have your answer. Number 19. Hey, number 19, you're given a table of values. So at x for value of x for 2. So the f at 2 is 0. The derivative at 2 is 0. The second derivative at 2 is 5, and so on. And then use that table to find this limit. So if I plug in the 2 for the function, the answer is 0. And 2 take away 2 is 0. It's indeterminate. So I'm going to do L'Hopital's rule. That's the derivative of the numerator and the derivative of the denominator. So actually, after I take it, I plug 2 in again, and I get, again, looking off the table, the derivative at 2 is 0, and this is 0. So I got to do it again. The derivative of the numerator and the derivative of the denominator. That's the second derivative, and the derivative of the denominator is just 2. Now plug it in. And the second derivative at 2 is equal to 5. So all you're left with is 5 over 2, or 2.5. And you have your answer. Number 20. Let g be a continuously differentiable function. G at 1 equals 6. The g prime at 1 equals 3. And you're given this limit. So step 1 for this limit, plug 1 in for x. If you're integrating from 1 to 1, that answer is 0. There's no area defined. 1 to 1, it's 0. And then if I plug 1 in for x, g at 1 is equal to 6. And 6 take away 6 is 0. It's indeterminate. So I'm going to take the derivative of the numerator and denominator. When you take the derivative of the integration, this is called the fundamental theorem of calculus. The derivative and integration undo each other. It's a substitution question, and all you're left with is g at x. The denominator, the derivative of g at x is that, and the derivative of negative 6 is 0. Plug 1 in again. The value of g at 1 is 5. The value of the derivative at 1 is 3, and you have your answer 5/3. Right? What did I do? Oh, the value of the function at 1 is 6. And 6 divided by 3 is 2. Number 21. The limit is h approaches 0. If I plug in 0 for h, e to the 0 is 1. Take away 1. So it's indeterminate. A lot of L'Hopital rule questions here. Take the derivative of e to the h is e to the h. The derivative of negative 1 is 0. The derivative of 2h is 2. Plug in 0 for h, e to the 0, and you're left with the answer 1/2. That's B. Number 22, a limit question. I wonder if it's L'Hopital's rule. It is. So that's 2x plus 1 and 2x. Plug in 2, and you get 5 over 4. Number 23. On a certain day, the total number of pieces of candy produced by a factory, since it's opened, is modeled by C, a differentiable function of the number of hours since the factory is open. So what does this mean? So during the third hour, what's the production? 500 candies per hour. That's the rate. So the rate is 500 candies per hour during the third hour. Turn the page. Which one says that? The factory is producing, the rate at which the factory is producing candy is increasing at a rate of 500 pieces per hour, 3 hours after it opened. The answer is C. So the factory is producing candy at a rate of 500 per hour, 3 hours after it opens. 24 has a calculator. A particle moves along there. You're given velocity. How do you find acceleration? Can you use your calculator? Try it first. Press pause. See if you can take the derivative at 3 and if it matches me or not.